Hi, Kinesiology 3010. Welcome to our Part 3 lecture on reliability and validity. Today we're going to focus more on criterion referenced reliability. So rather than looking at reliability within tests, looking at the population, we're now going to look at some set standards of what is sufficient or what is allowable, what is good, what is bad, as our reference for the reliability and validity measures we're going to take. Okay, remember when we look at norm reference standard, this is when we're comparing to a population or a group. Okay, so this is kind of within the population, within the group. What is normal? What is the average? What is consistent? What is the variability? What is the validity there? Compared to what is a criterion reference standard, which is where we are setting a set cut point based on a standard that everyone within that population has to meet the set standard. Doesn't matter if the population all meets it or none of the population meets it, but this is what we're comparing everything to. And so norm reference, we're looking at the population. Compared to a criterion reference, we're looking at a specific cutoff point for possibly a category or a classification, so like healthy, unhealthy, pass or fail. You do have to hit a criterion or a set standard to achieve that category. So when we look at the concepts of reliability and validity, like we talked about in our part 2 lecture, they are the same for both norm reference and criterion reference, but how we determine the reliability or determine the validity is a different statistical approach compared to our norm reference standard. Okay, so within human movement, most of what we're dealing with is a continuous scale measurement. And then we have some categorical or nominal variables like gender, race. These are categories, and there is a set cutoff for what falls into each of these categories. So these cutoff scores create forced boundaries within categories. So it forces us to have a standard and to reach that standard to fall within that category, rather than looking at what is normal within the population, or what is average, what is high, what is low. We're looking at these set cutoff points regardless of what the population is. So it's kind of a minimum standard. So some examples here are driver's license tests, where you have a cutoff score that you have to achieve. Looking at cholesterol levels, looking at physical activity participation. So the cutoff point is 150 minutes per week is the recommended physical activity per week for an active individual. So you have to reach that threshold to fall into the active category. We'll also talk with our youth fitness, the fitness gram, and healthy fitness zones. You have to achieve a very specific score to fall into each of the categories of the healthy fitness zones. So other examples looking at like certifications, continuing education, to pass or fail, maybe the ACSM, American College of Sports Medicine certification, you may have to have a very specific score to say you are a certified fitness trainer. If you don't achieve that cutoff score, then you don't earn that certification. So it's not based on how the population did, like you would see in like an SAT or a GRE assessment. This is a minimum standard to pass. So we're not looking at percentiles here. We're looking at a very specific cut zone. And this is often when we have a standard for maybe an expectation of knowledge. In this case, an expectation of knowledge on the subject matter. If you don't, or you aren't able to express sufficient knowledge within that subject area, you don't earn the certification that says that you have that content knowledge. So we have that very specific cutoff zone. If we just kind of said, oh, you tried, but they didn't score above that threshold, then we're going to say people have knowledge and when they really don't. And that could likely lead to injuries, lead to more harm than good. So we do have to have these specific criteria when we're looking at content knowledge, health zones. like blood pressure for hypertension. They're just saying, oh, well, it looks normal for you. Normal for you can still be unhealthy for the human body. Okay, so looking at this as sufficient knowledge, enough, meeting the minimum standard. Okay, so how we create these is by setting a standard for what we need. Rather than looking at the mean and the standard deviation, looking at what's normal within the population, we're looking at overall what is necessary to fall into this category. What is sufficient to be excellent? What is sufficient to be good? What is the level that's required to have this specific category? So we're not going to talk about how to create the criteria, but we're going to talk about how we can assess the reliability and validity of tests that are used to measure those cut points. So there's multiple different types of tests, like chi-square, proportion of agreement is the one that we're going to talk about for this class. There's the phi coefficient and kappa statistic, but we're going to talk about proportion of agreement for this class. A proportion of agreement is looking at how often we have a specific measurement that measures one quantity that it's supposed to measure, and then we have, it's kind of like proportion of agreement in the sense of we're looking at agreements divided by total number of possible options. So we'll go into a little bit more detail here, but make sure you take a note of the formula here. You're going to need it for your final exam. Okay, so let's look at this test that we're using to achieve, say, a cutoff point, whatever arbitrary cutoff point. And we're looking at trial 1 and trial 2, and we're trying to see if there is reliability within this test. Does this test measure that an individual who would pass this test will pass in both scenarios? An individual who will fail in the first scenario, will they also fail in the second scenario? And how often are there disagreements where they pass in one and fail in the other, or fail in one and pass in the other? Okay, so there's 4 possible categories or 4 possible scenarios when we're looking at this 2-trial model. So we can have pass the test in trial 1 and pass the test in trial 2. We consider that N1. Okay, only passing trial 1 but failing trial 2 is considered N2. Only passing in trial 2 but failing in trial 1 is considered N3, and failing a test in both trials, so fail, is considered N4. Okay, we create a little small matrix for this to look at pass, fail, pass, fail, pass within that criteria. So let's look at more of an example. Okay, let's say we have 150 students that take a skills test. And we find that 84 students pass, so we consider that N1. So you can mark that as N1 within your little matrix, your little box. 21 students passed the first test and failed the second, so these are the pass-fails, or the N2s. We had 5 students that were fail-pass, or N3, and 40 students that were fail-fail. So if we look at this here, we have our pass-pass and our fail-fail, and our fail-pass and our pass-fail. So how do we analyze this? How do we determine the reliability here that this test that measures a cutoff point, or measures if you pass based on this criteria? We need to know that this test will accurately, or not accurate, reliably, so repeatedly measure individuals who pass, will pass, and then pass again. Okay, so they will consistently pass. Those who fail will consistently fail, and we won't have as many of these options where we're not measuring the same in both tests. So looking for minimizing the pass-fail and the fail-pass groups to improve reliability, because then we're going to consistently measure meeting the criteria or not meeting the criteria. Okay, so if we look at these in trial 1, trial 2, we're looking at pass-fail, pass-fail. So if this makes a little bit more sense, so pass-pass, pass-fail, pass-fail, and fail-fail. looking at these groups. Now we plug this into our equation for the proportion of agreement. So looking at how often that we have pass, pass, and fail, fail divided by the total number of possibilities. So the total number of pass, passes, total number of fail, fails, and the total numbers of pass, fail, and fail, pass. Okay, so in this case, here we have 124 agreements out of 150 possible cases, which gives us a reliability or a proportion of agreement of 0.83. So the reliability of this criterion reference test is 0.83. So we're looking at this as an individual cutoff point and looking at how well this test repeatedly measures the same individual passing both times or failing both times. Okay, so in this case, only 17% of the time a participant would pass in one scenario and fail in another. Okay, so this is good reliability. So let's look at a couple more examples. Okay, so here's an example for, say, a tennis skills test. Say we're looking at the wall volley test. So we're looking at how well this will determine who should enter as an intermediate tennis player. So we're looking here at trial 1 and trial 2. So in this case, we have to hit the ball across the line into the wall repeatedly without making errors. Okay, so our set standard for passing this test is to have 25 successful hits. Okay, you must hit the wall against the front wall at least 25 times in the trial to meet the standard for entry into the category of intermediate. Okay, so we're looking at this as the cut point. So 25 hits within the time period puts you into this intermediate category level. Okay, so we're putting this as our category. It's either pass as intermediate or fail to be intermediate. Okay, you want to see if this player can achieve the standard for each trial and looking at consistency. So we're looking at reliability here because we see that keyword consistency. That means we're looking at the reliability of this. So let's look at what happened in our example. Okay, so trial 1, we're looking at those who failed to meet the standard in both scenarios. So looking at trial 1, those who failed to meet the standard, those who met the standard. And then looking at in trial 2, those who failed to meet the standard and those who met the standard. So people who were fail on both trials, people who were met standard on both trials. So our N1 and our N2, and then our those who failed in one scenario and met in the other, and met in one scenario and failed in the other. And we see that there's in this scenario, we look at the trials. Here we have multiple participants. Looking at trial 1, trial 2. Here we have 18 participants. So we find that 7 fall into this N1, okay, which would be our pass. We look at 6, see here our fail, and then we see 2 and 3, so 5 total are within the pass/fail/fail pass groups. So this is using this model of if they met or failed to meet, and met, failed, or in between, or one of each. Okay, so if we map these out, okay, how many did meet the standard in trial 2 and trial 1 would be 7, as we saw before. 6 did not meet in each, and 2 and 3 for the met in one but did not meet in the other. Okay, this gives us a total of 18 total occurrences. And we find that if we add 7 plus 6, so that's 13. So 13 times we found the same outcome in both measurements. So that's where our consistency is. Out of the total number of occurrences, which is 18, gives us a reliability of 0.72. So we don't have great reliability, so we have moderate reliability here with this test. It's not good reliability, but it's moderate because it's below that cutoff point of 0.8 for our good reliability. So it's moderate reliability. We're seeing this frequently, but it's not perfect. Okay, so now how do we test for validity? We talked about reliability. Now we say we have a reliable test Now we need to know if a test is valid. Okay, remember, validity tests the truthfulness or how well our measurement measures what we think we're measuring. We need to develop a criterion for these skill scores. So we can use expert opinions. Okay, we can use some other set standards. But in this case, we'll use some expert opinions because that's what we mostly use for a content-related reliability for most of these. So say we use this same test and we want to know, is this test valid for determining if someone is actually an intermediate tennis player? So we have our standard for passing, but now we need to know if this is really a good measure or reliable measure, truthful measure of someone's tennis playing ability. Okay, so we can use coach's observation, we can use competition performance, we can use experience level. So we can say that inexperienced would be a novice playing less than 4 years, and experienced, skilled, or playing more than 4 years. So if we have our coach standard say, yes, this is an experienced player based on the subject matter expert, or this is an inexperienced player based on subject matter expertise and experience. And then you want to see if those who are categorized as experienced will achieve the standard of intermediate or experienced, and those who do not will be categorized as inexperienced. So we're trying to validate if this test can measure someone's experience level or someone's ability within that measurement. Okay, so we use our expert, have them view their tennis performance, look at inexperience and experience level, so how you would categorize them based on watching them play. And then we have them perform our field test of hitting the ball against the wall and back a minimum of 25 times in 60 seconds. So this is our cutoff to fall into the intermediate tennis level. Now what we're going to do is still use that proportion of agreement, except we're going to compare how often the coach agrees with the measurement. So how often do people who meet the measurement standard also get categorized as experienced, and those who do not also get categorized as inexperienced? So how well that the coach and the field assessment agree on the same category for each individual. Okay, so we bring it back here. So we're looking at our same proportion of agreement. So how often they pass the test and were categorized as by the coach as experienced. How often they passed the test but were categorized as inexperienced. How often they failed the test but were categorized as experienced players, and those who failed the test and were categorized as inexperienced. Okay, so what we expect, and then disagreements within the test and the expert. Okay, so here we see that we have 7 players that are categorized as experienced and pass, and 4 that are and 7 that are categorized as inexperienced and don't pass, as well as 2 that failed and passed, and those who 2 that passed but were categorized as inexperienced. So we'll plug these into our proportion of agreement. We see that there are 7 plus 7. Okay, our N1 and our N4 are 14 out of 18. So this has moderate validity for tennis skills. So this criterion test, based on our assessment of its validity with our expert, we found that it has moderate validity to measure tennis skill. So we have about 22% of the time we are not validly measuring someone's experience from an expert's level compared to just this test's measure of their experience level or their skill level. Okay, so we can use this same test to assess both the reliability and the validity of our criterion measurements. Okay, so there is some logic behind applying these. So we can use these tests for looking at stability, how often we repeatedly achieve the same score on test after test after test. But if we're looking at the validity of a criteria, we need to have something like a subject matter expert or data on how well they perform within their sport, uh, or how well they perform within these activities on a different assessment that fits, that is known, that is validated to fit the criteria. So we have to have some kind of expertise or some kind of other standard to compare our test to assess its validity. Okay, so we can apply this to things like epidemiological research, so looking at disease and disease rate. So some categories in this field is alive or dead, or which is pretty clear cutoffs there. Disease or no disease, active, inactive. So for example, here we have your cholesterol level above 240. That's a criterion that is identified as a high level, and it may be related to heart disease. Researchers want to test this theory. So they take subjects with high cholesterol and subjects with low cholesterol and compare this criteria against what is related to heart disease risk. So what are the symptoms and the measurements of heart disease compared to this criteria of high cholesterol? So we want to know, is this actually a measure that relates to heart disease? So we take those who have high cholesterol and not high cholesterol or normal cholesterol, look at the rate of heart attack deaths and non-heart attack deaths. So basically heart disease mortality, not heart disease mortality. Look at how often that these agree that the high cholesterol will pass due to heart attack mortality or heart disease outcome. Okay, in this case, if we do the math here, looks like we have some pretty low validity here because we have 62% of the time that a high cholesterol individual passes from a heart attack, and or a no high cholesterol person does not die from a heart attack. So that still leaves us with some moderate to lower validity, some moderate validity within this test. So it's not saying that high cholesterol is directly related or directly influences heart disease risk in this case. Okay, we could also look at it for things like smoking. So looking at people who are smokers and non-smokers, and are they dead or alive after a certain period of years. So you could design this study and looking at over time, okay, over 5 years, over 10 years, how often the smokers die, or the smokers or the non-smokers don't die, and how often that agrees over that period of time. And we can also look at it with physical activity, so those who are sedentary compared to those who are physically active, and design a study to look at how sedentary or lack of activity relates to mortality, and physical activity relates to longevity. So looking at how well that saying you are sedentary also says you are at risk for this or that mortality measure. All right, thank you very much for watching our video, and I'll see you next week for our next one.